Welcome to this lesson on esters, one of the most interesting groups of organic compounds. Esters are known for their pleasant, fruity smells and are found in many everyday products. Today, we'll explore how these compounds are formed from the reaction between carboxylic acids and alcohols. Esters are organic compounds that contain a characteristic functional group. They form when carboxylic acids react with alcohols. The general structure of an ester is represented as R-COO-R', where R and R' are hydrocarbon chains. The COO group is called the ester linkage, which is the key feature that defines this class of compounds. The formation of esters is called esterification. In this reaction, a carboxylic acid, represented as R-COOH, reacts with an alcohol, R'-OH, in the presence of an acid catalyst, typically a hydrogen ion. The products are an ester, R-COO-R', and water. This is a condensation reaction because a small molecule, water, is eliminated during the process. Two key components are needed to form an ester. First is the carboxylic acid, with the formula R-COOH, which provides the carbonyl group and oxygen. Second is the alcohol, R'-OH, which contributes the alkyl group. When these two react together in the presence of an acid catalyst, they combine to form the ester linkage. Let's look at a specific example. When acetic acid, CH3COOH, reacts with ethanol, CH3CH2OH, they form ethyl acetate, CH3COOCH2CH3, and water. Ethyl acetate is a common ester with a distinctive fruity smell similar to pineapple. This compound is widely used as a solvent in nail polish removers and adhesives. Different esters have different characteristic smells. Ethyl acetate smells like pineapple. Pentyl acetate has a banana-like aroma and is often used in artificial banana flavoring. Octyl acetate gives an orange scent. Methyl salicylate has a wintergreen smell and is commonly used in pain relief creams and liniments. These pleasant fragrances make esters valuable in the food and cosmetics industries. Esters have several important properties. First, they have pleasant, fruity smells, which makes them useful in perfumes and flavorings. Second, they are less soluble in water compared to carboxylic acids because they cannot form hydrogen bonds as effectively. Third, esters have lower boiling points than the corresponding acids due to the absence of hydrogen bonding between ester molecules. Finally, esters can undergo hydrolysis, which is the reverse of esterification, breaking down into acids and alcohols. Esters have numerous practical applications. They are widely used as flavoring agents in food and beverages to provide fruity tastes. In the cosmetics industry, esters are key ingredients in perfumes and fragrances due to their pleasant smells. As solvents, they are found in paints, varnishes, and nail polish removers. In pharmaceuticals, esters are used in drug formulations, including aspirin and other medications. Their versatility makes them one of the most important classes of organic compounds in both industry and everyday life.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.